All right, now where this whole lesson's been headed is here. We've been talking about how many possible zeros something could have and how to find them, all that stuff. Now we're going to talk about whenever you see a degree of n. So remember, that means the power. If the power is 5, what this says is it does have 5 zeros. It's just some might be imaginary. Some are real, some are imaginary. Here's what you know about what you need to know about imaginary. If you have one imaginary, you will always have at least a second with it. Imaginaries always come in pairs. They never come alone, okay? So they always come in pairs. The linear factorization says we could always factor an equation down. We just might have to have some of these being imaginary. And you'll see that as we come through. Here is, we're going to start by writing polynomial functions. So it says of least degree. That means the fewest power necessary. And it has the coefficients in a standard form that has -1, 2, and 2i as a 0. This, you need to know, is imaginary. This is imaginary. Now, what did I just tell you about imaginary is they always come in pairs. Since they always come in pairs, since that's true, we also have 2 plus I as a 0. So here's how you can write this out as linear factorization is what it's called. And here's how we do this. We'd say f of x equals, now if this is the 0, this comes from x plus 1. This one would come from x minus 2. So what you'd have is an equation that's x plus 1 times x plus 2, or x minus 2, I'm sorry, times, now this one, you got to be slick here, because it's going to be x, remember the sign switches here, minus 2 plus I. Now don't get carried away with, whoa, do I switch this I, do I not? Because you're always going to have two of them. You'll have one with a positive I and one with a negative I. What you just need to know is the number values always switch. So this one would be -2 minus I. So both signs will switch. You just need to have both there. Now that would be how you write it as a linear factorization. Now that's the simplest way of writing the equation. And by the way, if you ever need to just take a shortcut, you could do it like that. However, you could also write it out and simplify it, and the I would disappear. Let me show you. When you multiply this out, if we FOILed this, FOIL x plus 1 times x minus 2, if you FOILed that out, we would get first times first is x squared minus 2x is the outside, inside is plus x, and then minus 2. So we would have there x squared minus x minus 2. So that comes up here and replaces those first two parentheses. Now we'd go over to this. Now you could do FOIL here. Once I get 3 times 3 terms, I use box method. Okay, so I would come over here and I would do like a box method. And how that works is you just draw a box and do your linear factorization or your multiplication from this box. So it's a 3 by 3. Whoops, I need to have 3 lines in here. Let me get this straight. I'm sorry. Yep. And you got 3 terms there, and you're going to have 3 terms on the top. So you put one there and another one there. Now we're going to multiply across our values once we have them up here. So we have x minus 2 plus I. That's that parentheses. And now this one, x minus 2 minus I. Now if we do this correct, all the I should always cancel out. So x times x is x squared. And then you would have -2x here and positive ix. Here I have -2x, and -2 times -2 is +4. And then we'd have -2i. Here I have -ix, positive 2i. And finally, negative I times negative I is -I squared, which if you don't know, I squared is equal to -1, so that's actually equal to 1 because the negatives would cancel out. that'll equal 1. So now we can cancel out some other things. This right here cancels with this one. This simplifies with this one. See, the i's always disappear. They always do. And so what are we left with here? We would be left with x squared minus 4x plus 4 plus 1. And so that's what you would multiply these two with. X squared minus 4x, and that would become plus 5 there. And now we could do one more box method to simplify one more time. So I'll do another box method here. And I'll pause this just to draw my boxes. And now I'll fill in my terms. So we have x squared here, minus x, minus 2. That's that parentheses times this one, which was x squared minus 4x plus 5. And I multiply across here. X squared times x squared is x to the 4th. X squared times negative x is negative x cubed. Negative 2x squared. This is negative 4x cubed. This would be positive 4x squared. This is positive 8x. Positive 5x squared here. And negative 5x. And finally, negative 10. We combine our like terms, which we can see a few of them will combine. So I have x to the 4th. I have a negative 4 x cubed and a negative x cubed. I'll also have the squared terms here. So I have a positive 5x squared, positive 4x squared, minus 2x squared. I have these two, a positive 8x, no, negative 5x, I'm sorry. And then I have a minus 10. So if I wanted to write my answer simplified, I would say, I'm working up here if you're wondering. I'm going from there up. You would have x to the 4th, these three right there, that. We have negative 4, negative 1, and positive 5. I owe 4, I owe 1, I have 5. Those, oh, I'm sorry, that's a squared. Let's just go here. That is negative 5x cubed. So I have minus 5x cubed here. Combine these, positive 5, positive 4, and minus 2. That's like having 7x squared, positive 7x squared. We combine these two to have plus 3x. And then, of course, the minus 10. That is the best answer. Notice the i's have totally gone away. Now, you can try one. I would recommend you just write out the linear vectorization though. Note that if you're 0, that's just going to be x. And remember, multiplicity would mean x plus 2 squared for that one. All right? So keep that in mind.